Hello everyone, today let's see what are the parts of a rocket.
What is a rocket? Everyone knows rockets can fly, and you also want to fly to space using a rocket, right? But do you know how rockets are made up of? In this video, let's see what are the parts of a rocket. But before that, let's see what is a rocket. In simple words for easy understanding, a rocket is a space vehicle with a very powerful engine designed to carry people or equipment beyond Earth and out into space. Parts of rocket. Rocket engines work by action and reaction and push rockets forward simply by expelling their exhaust in the opposite direction at high speed and can therefore work in the vacuum of space. There are four major parts or systems in a rocket. They are structural system, payload system, guidance system, and propulsion system. Structural system. The structural system is the frame that covers the rocket. It is made up of very strong but lightweight materials like titanium or aluminium. Fins are attached to some rockets at the bottom of the frame to provide stability during the flight. Two or more of the basic structural types may be combined in a single structure, such as a building or a bridge, in order to meet the structure's functional requirements. Tensile structures. Numbers of tensile structures are subject to pure tension under the action of external loads. Compressive structures. Compression structures develop mainly compressive stresses under the action of axial loads. Trusses. Trusses are composed of straight members connected at the ends by hinged connections to form a stable configuration. Shear structures. These are structures such as reinforced concrete or wooden shear walls which are used in multi-story buildings to reduce lateral movements due to wind loads and earthquake excitations. Bending structures. Bending structures develop mainly bending stresses under the action of external loads. Next one is payload system. Payload is the object that the satellite is carrying into the orbit. Payload depends on the rocket's mission. The rockets are modified to launch satellites with a wide range of missions like communications, weather monitoring, spying, planetary exploration, and as observatories. Special rockets are also developed to launch people into the Earth's orbit and onto the surface of the Moon. In a commercial context, that is an airline or air freight carrier, payload may refer only to revenue-generating cargo or paying passengers. A payload of ordnance carried by a combat aircraft is sometimes alternatively referred to as the aircraft's warlord. For a rocket, the payload can be a satellite, space probe, or spacecraft carrying humans, animals, or cargo. For a ballistic missile, the payload is one or more warheads and related systems. Their total weight is referred to as the throw weight. Next, let's see about the guidance system. Guidance system guides the rocket in its path. It may include sensors, onboard computers, radars, and communication equipments. Guidance is a process of calculating the changes in position, velocity, altitude, and or rotation rates of a moving object required to follow a certain trajectory and or altitude profile based on information about the object's state of motion. A guidance system is usually part of a guidance, navigation and control system, whereas navigation refers to the systems necessary to calculate the current position and orientation based on sensor data like those from compasses, GPS receivers, Lorentz star trackers, inertial measurement units, altimeters, etc. The output of the navigation system, the navigation solution, is an input for the guidance system, among others like the environmental and the vehicle's characteristics. One of the earliest examples of a true guidance system is that used in the German V1 during World War II. The navigation system consisted of a simple gyroscope, an airspeed sensor, and an altimeter. The next one is propulsion system. Spacecraft propulsion is any method used to accelerate spacecraft and artificial satellites. In space, propulsion exclusively deals with propulsion systems used in the vacuum of space and should not be confused with space launch or atmospheric entry. In space, propulsion begins where the upper stage of the launch vehicle leaves off, performing the functions of primary propulsion, reaction control, station keeping, precision pointing, and orbital maneuvering. Most satellites have simple, reliable chemical thrusters, often monopropellant rockets or resistogen rockets for orbital station keeping, and some use momentum wheels for altitude control. Soviet bloc satellites have used electric propulsion for decades, and newer Western geo-orbiting spacecraft are starting to use them for north-south station keeping and orbit racing. Interplanetary vehicles mostly use chemical rockets as well, although a few have used ion thrusters and all-effect thrusters to great success. Thank you by Betsy Victoria.